We are looking at gas laws today. So there are a couple ones that we went over in the lecture, and we're going to be basically just practicing how to use their formula and basically how to solve for it. So there's three things that we're going to look at. We're going to look at, oh, that's the eraser. We're going to look at pressure. We're going to look at temperature. And we're going to look at volume. So in the formula, there's one formula that you'll use all three of them. And then for the other ones, for the most part, you're trying to solve for one of them. Also, one might be held at a constant, which basically means it's missing. So pressure, you will see it as ATM or millimeters of mercury. Okay, so mmHg. Temperature, it's going to be in Kelvin. If it's not in Kelvin, you need to convert it into Kelvin. So if they give it to you in Celsius, basically what you're doing is you're going to add 273, and that'll give you Kelvin. And then volume is going to be in liters. So if it's not in liters, you're going to have to convert to liters. Same for pressure, but for the most part, I'm pretty sure all the problems that we're going to be working on are already in ATM or millimeters of mercury. You might see something that says STP, and in the notes it says it like very briefly towards the end of the PowerPoint, but basically this is standard temperature and pressure, which is going to be, your pressure is going to be 1 ATM, and then your standard temperature is going to be 0 degrees Celsius, so then you can just convert that into Kelvin. Okay, so the first thing that we're going to look at is Boyle's law. So Boyle's law formula is P1, V1 is going to equal P2, V2. So basically P1 and V1, that's going to be what you start with, and then P2 and V2 is going to be what you end with. So this is your start, this is your end. And basically, depending on what they're asking for, it's just basic math from algebra. So whatever variable is missing, you're going to send the one that it's paired with over to the other side dividing. So we'll look at it in this problem. So Boyle's law says, use Boyle's law to answer the following questions. So 1 liter of gas at standard temperature and pressure is compressed to 473 milliliters. What is the new pressure of the gas? So what I like to do is I like to list out everything that's stated to me. So I like to list out my P1, my V1, my P2, V2. So it tells me that 1 liter of gas at standard temperature and pressure. So 1 liter is going to be our volume, 1.00 L. We said that standard temperature and pressure, STP, is going to equal 1 ATM or 0 degrees Celsius. So this is Boyle's law. There is no temperature in the formula. Okay, so that means we're going to plug in the standard pressure, which is going to be 1 ATM. And then it says it's compressed to 473 milliliters. So your second volume is 473 ml. And it wants to know what's the new pressure. This is in milliliters. This is in liters. We've got to convert it. So if you remember from earlier in the year when we did conversions, basically you have to move the decimal point. If you don't remember the exact formula, you can always use King Henry doesn't mind drinking chocolate milk. Liters is going to be in this area. So liters, grams, or meters is right there. So 473, it's in milliliters. So it's going to be over back here. And you got to move it until your decimal place gets here. So that's going to be 1 place, 2 place, 3 places. So you have to move your decimal 3 places. So 473 milliliters is going to actually equal 0.47. Oh, that is not a 7. 473 liters because we are moving it 1, 2, 3 spaces. Okay. So let's go back a little bit. Now we've got what we need to solve for the second pressure. So I like to write it all out and plug it into the formula. So 1 ATM, you want to make sure you include your units, times 1.0 liters is going to equal P2 times 0.473 liters. Okay, we want P2 by itself. So what we're going to do is we're going to send this volume over to the other side. Since these two are multiplying each other, you're going to get rid of this by sending it over dividing. So you're going to do 0.473 liters. That's going to cancel with this. And you're going to do the exact same thing on the other side. 0.473 liters. You're dividing by liters and you're multiplying by liters, so that cancels. And you're going to be left with ATMs. So 1 ATM times 1 is going to give you 1 divided by 0.47, 73 liters. Not liters, oh my goodness, ATM. And when you plug that into your calculator, you will get 0. You will get 2.11 ATM as your pressure too. Okay, let's try the next one. So it says in thermonuclear device, the pressure of 0.5 liters of gas within the bomb casings reaches 4 times 10 to the 6 ATM. When the bomb casing is destroyed by the explosion, the gas is released to the atmosphere where it reaches a pressure of 1 ATM. What is the volume of the gas after the explosion? So again, I like to list out, let's change the color a little bit. P1, V1, P2, V2. It says the pressure of 0.05 liters. So that's going to be our first volume, 0.050 liters. Within the bomb casing reaches 4.06 times 10 to the ATM. So that is our our first pressure. So 4.0 times 10 to the 6 ATM. When the bomb casing is destroyed by the explosion, the gas is released to the atmosphere where it reaches a pressure of 1 ATM. That is our new pressure, so 1.0 ATM. What is the volume? So we're looking for the volume now. So I'm going to plug it into my formula. So remember the formula is P1 V1 equals P2 V2. So let's change the color again. We're feeling purple. So 4.0 times 10 to the 6 ATM times 0.050 liters is going to equal 1.0 ATM times V2. Okay? You're going to send this over dividing so you can get V2 by itself. Do the exact same thing on the other side. I'm so sorry about my cat. So V2 is going to equal, we're going to cancel this ATM. We're going to cancel this ATM. Since this is 1, you're not really doing anything with it. So you're just going to multiply up top. So I'm going to do 4 times 0.05 is going to give you 200,000 liters. So that is your new volume. Okay, and that's basically what you just do is you're just going to plug in the numbers and solve for the variable that's missing.